All right, greetings, YouTube. This is Beautiful Mind. So we decided to do a live session now. We have an exam coming up, so I told my students that I'll hold a live session. Hope everyone's been having a great weekend. It's been homecoming weekend. I did not get a chance to participate in the festivities, but I did have a great weekend so far. So we'll go ahead and get started with this assignment. Hopefully everything is going well. Once I see people logging in, we'll make sure that the audio is working properly. Hello, hello, welcome, welcome. So I see you log in. You've logged in. Let me know. Can you hear me? Let me know if you can hear my audio. Just say a yes or yes, we can hear you or something of that nature. Also, be sure to leave a comment in the comment section. You can use the chat for communication, but leave a comment in the comment section. And that's how I will give you credit for attendance. Okay, so let me see. Let me type something. Yes, yes. And I see welcome. Okay, so it seems like, okay, good. You guys can hear me. All right. So what we're going to do again, welcome, gentlemen. Hope you have been having a great weekend. So we're just going to continue this live session. I see you all logging in. I don't know what happened with the homecoming, so just kind of update me. I just been having a great weekend, enjoying myself. But I said we were going to have this session, so it should be pre-cal students and basic math students here, so I'll just kind of answer questions as they come. All you have to do is go to the study guide and then click on Ask My Instructor for whichever question and send it to me in the email, and I'll incorporate it into the video. All right, and then also just be sure to go to the comment section and leave a comment, and like with your information or whatever, like your name or something in your class, so that I can give you credit for attendance right now. Otherwise, I'm going to start with one question that someone asked, and we'll go from there. Okay, so you can either type in the live chat, but be sure to go to the Ask My Instructor, and I'll get an email and I'll incorporate it into the video. All right, so our first question comes from PreCal. So this comes from section 4.5, question 27 in PreCalculus, and it says find the exact value of y, or state that y is undefined. Okay, so we're going to just start here, and then as people have questions, I'll kind of entertain them. So now in PreCalculus with something like this, when we have a trig function composed as inverse trig function, the first thing we need to kind of be clear about is the domain and range of our trig. So what I usually do for something like this, it's a little bulky, but it seems to be working okay for me. So like if we're doing tan, for instance, I know that tan of theta, for instance, now if I think about the graph of tan, right? So say this is the graph of tan, just a quick sketch. I know at 90 degrees, it's undefined. At negative 90, it's also undefined. Let me see. Because you have sine on top. Sorry, I think that might be wrong. Hold on. Let me back up. So tan, I kind of go through this whole little process. So tan of theta is sine of theta over cosine of theta, right? So tan is going to be 0 when the numerator is 0. So when is sine 0? Sine is 0 at the origin, and then at 180 degrees, 360, basically at pi, 2 pi, 3 pi, so on and so on. So that means that tan is going to have its zeros at the origin, and then pi, so on and so on. So if I'm thinking about the graph of tan, so then I know at the origin, tan is going to be 0. Then tan is going to be undefined when cosine is 0. Cosine is 0 at 90, and then the odd multiples of pi over 2, basically. So yeah, at 90, tan should be undefined. At negative 90, tan should be undefined. All right, and then it kind of continues that pattern. So I know that the graph of tan goes like this, right? So now, if this is the original graph of tan, we see that if, in order to talk about an inverse trig function, we have the restricted domain. So for here, we'll see restricted domain from negative 90 to 90 with parentheses, because of the asymptote, so they get parentheses. And then the range, so this is tan of theta. Then the range we see is all real, so negative infinity to infinity. I kind of go through this whole little thing every time I do it, because this is what I see. Then if we did inverse tan, so tan inverse of some number, I'll just say x or whatever. So inverse tan of something. Then if this is if the domain is negative 90 to 90, then the inverse 10, this is going to be our range, and this is going to be our domain. Okay, so then this is what I do every time. So now, because 10 is on the inside, that means our domain, we got to use the part on the left. So our domain is from negative 90 to 90, and then the outputs are going to be negative infinity to infinity. So you see how our theta that we have is 7 pi over 10. So, all right. So then we know that, let me see. Okay, so then usually we have what? Tan of some angle is going to be, I think we said y over x, all right? Let me think about this for a second. Let me see something. I don't want to waste too much time thinking about this. Okay, so let's see where the 7 pi over 10 is. Let's see if it's between negative 90 to 90. Let me see something. So I'm looking at the view and example, and it says for the tan function, the following properties hold. You have inverse tan of tan is x, and so on and so on. When x is between the negative 90 to 90, and then vice versa, the whole argument that we had before. But so you can apply the property directly when your x is in the proper domain. Now, if it's not in the proper domain, we have to find the angle y in the interval so that it's true. So like 7 pi over 10, let me just convert that to degrees really quickly just to see what that is. So if we have 7 pi over 10, and I'm going to multiply by 180 over pi, so that turns this into an 18, then that's 70 plus 56. 126, is that right? Give me 1 second. So 7 times 18, 126. So it's 126 degrees. Notice this is not on our interval from negative 90 to 90. Okay, so that means we can't apply the property directly and just take that theta. Let me see. So now we got to find some angle so that tan of the 7 pi over 7 pi over 10 equals tan of y. Okay, that's fine. Give me 1 second. Okay, so I'm just going to convert. So we're talking about 126 degrees. So that's in quadrant 2. And then, so if we're in quadrant 2 and we're at 126, let's just do the 180 minus 126. So 180 minus 126. So we need to find an angle that's 54 degrees away from the x-axis that has the same output. So we basically need to be 54 degrees away from the x-axis, either in quadrant 1 or quadrant 4. And we need to have the same result when we take tan of 7 pi over 10. Okay, so let me do that really quickly. Now, if we think about it, if the 126 is in quadrant 2, it's going to have a negative slope, so that result should be negative. So my intuition would say we should be in quadrant 4, 54 degrees away from the x-axis in quadrant 4. So let me see. So then if we're 360 minus 54, that means 306. So I know that's a little bit bulky and cumbersome, but we should be at angle measure 306 degrees in quadrant 4, and then we just convert it to radians. So let me do that conversion. So now we'll say times pi over 180. So then I'll just say the 306 divided by 180, and I'll do fraction. So it should be 17 pi over 10. Pi over 10. So this should be our reference angle in quadrant 4. We should still be 54 degrees away from the x-axis, but in quadrant 4, we should get the same output. So we're saying that this should be our result. I'm just going to check this really quickly in the calculator, and we'll do a quick recap. I know that was bulky. You got to do the best you can with that one, at least for my presentation. I'm just going to do a quick, so let's go here. This is a quick check in the calculator. All right. So now I want to do inverse tan, all right, of tan of 7 pi over 10, and I need to be in radians, okay? So then we hit it, we get some result. Oh, and it's negative. We forgot our negative. We did say it was negative. Okay, so now if we put in our radian measure, negative 17 pi over 10, we should get the same thing. Now let's see, what do we do wrong? So we converted it. Let me try one other thing. Yeah, 17 pi over 10. Yeah, let me see. Oh, no, didn't make that mistake. Okay, give me a minute. Okay, so it says to first identify the quadrant which the given angle lies. So like in their example, theirs was in quadrant 2. So then they found the reference angle. They found how far away from the x-axis they were, which is the same thing we did. Have a negative tangent, yep. Negative pi over 6, yep. Oh, we just want the reference angle. Oh, okay, I see. Oh, okay. So our reference angle was 54. I think it's just the 54. Let me try that real quick. I see what I was doing wrong. Oh, I see. It should just be the negative 54 degrees. Okay. So if I convert the 54, okay, I think I got it. So let's come back to this. Sorry about all the back and forth. Okay, so I think we had the idea, we just didn't do it properly. So now our reference angle, we said we needed to be 54 degrees away from the x-axis in quadrant 4. Now, that 306, that's not between negative 90 and 90, I just realized. So, but the negative 54 is. So I think we just need to convert the negative 54 to radians. So I'm going to say the 54 divided by 180 as a fraction. And it should be a negative 3 pi over 10. So let's write it that way. I think that's what we were missing. So then we should be talking about a negative 3 pi over 10. Let's try that and see if that works. So let me recall the original again. Okay, so this was the original. And then let's do the negative 3 pi over 10. Yeah. So we had the right idea. We put it in the incorrect form. Okay, let's do a quick recap. And again, this is for pre-cal. Okay. So we have this original, right? The inverse tan of tan. Now, if that theta, like, because tan, we saw that tan needs to be between negative 90 and 90. But if this theta were between negative 90 and 90, then we can just take the result directly. But because it was outside our domain, we had to find the reference angle that was similar. So then we see that 7 pi over 10 is really 126 degrees, which means that's in quadrant 2. In quadrant 2, tan has a negative slope, so tan is negative in quadrant 2. Also, we're 54 degrees away from the x-axis in quadrant 2. So then that means our angle still needs to be 54 degrees away from the x-axis, but it's either in quadrant 1 or quadrant 4 because of because of this right here. Now, ours was in quadrant 4 because that's the only quadrant where tan is going to be negative. So then we knew we had to be 54 degrees away from the x-axis in quadrant 4, and if we had just done the negative 54 in radians, that would have been it right there, which that's where we got the negative 3 pi over 10. We converted it to 360 minus that, and that was outside of our domain again. So we just had to put it back into the negative 90 to 90, which was just negative 54 degrees, convert it to radians, and then we're good to go. Okay. So I know that one was a bit bulky. I think that's the most challenging part of this section, of the whole pre-cal, in my opinion, this little discussion here. But beyond this, I think everything is a lot easier, a lot more simple. All right. So, that's how that one went. I think I had another student that emailed me a question, so I'll pull that one up. Also, for your credit, go to the comment section, like in the not in the live chat window, but in the comment section, and leave it there. Because once the chat is gone, I'm not going to be able to see it. I'd rather you do it in the comment section, so that way I can get it later. Let me pull up another question really quick. Gentlemen, you've been having a good weekend. Anybody do anything interesting for homecoming? And don't put your business up there. Just anything that's that you can actually talk about. While I pull up this other question. All right, I'm gonna get rid of this one. Actually, let me plug it in to see if it's correct. Hopefully, they didn't change. I think they did change it, so I'm gonna do this one again, just with another question, to see if how well versed I am. So I'm just gonna do it again, real quick. So this one says it's the same question. It just says find the exact values of. So this is I'll just copy and paste again. All right. Serve food at Hoko. What's Hoko? Habitat or hands-on something? I don't know. All right. So let's try this one more time. So now we just did 10. 10 is on the inside. So we know that 10 for the original, 10 of, I don't know, we'll just say X for now. I like beta. 10 of some angle, we restrict our domain from negative 90 to 90. Okay. And then the range goes from negative infinity to infinity. So the restrictions on these inverse trig functions you have to know. Then for inverse 10, I'm going to say inverse 10 of y. This will be our domain. This will be our range. So now since tan is on the inside and not inverse tan, since tan is on the inside, that means our angle needs to be between negative 90 and 90. Now we see we have this 2 pi over 3. So I'm going to convert that to radians to see what that is. 2 pi over 3, to degrees, times 180 over pi. This is gone. That's a 6. So that's 120 degrees. So notice this is outside of our domain, so we have to do this whole conversion thing. If this was between negative 90 and 90, then we could just take the answer as is. So now if we're talking about 120 degrees, we are in quadrant 2, and we are 60 degrees away from the x-axis. So we're 60 degrees away from the x-axis in quadrant 2. Now, if we're 60 degrees away from the x-axis in quadrant 2, that means tan is negative, because quadrant 2 has a negative slope between that point and the origin. So that means our angle is going to be 60 degrees away from the x-axis in quadrant 4. So our answer is really just negative 60 degrees, and then we got to convert it to radians. So then to convert, I'm going to say times pi over 180 degrees. Okay, degrees are gone. We're left with radians. Negative pi over 3 should be the result. I'm going to check it in the calculator before I submit that answer, just to be on the safe side. So let's check the calculator. All right. Oh, homecoming. Oh, okay. Serve food at homecoming. With what group did you serve with? Yeah. All right, let's check this real quick. So we got inverse tan of 2 pi over 3. All right. So make sure we're in radians. We are. So we get this result, right? Okay. So then we just want to make sure that's the same as our radian measure. Negative pi over 3. We're good to go. Okay. So let me go back to this. And then I'm going to go and plug in the answer that we got and make sure that it works. All right, let's act funny. Let's see if I can try this. So then negative, you don't let me type. Here it is. Okay. You see? So we said we got negative pi over 3. All right, let's hit enter. Fantastic. All right, so we got that one right. Oh, is that a Jamaican club or something? That sounds delicious. Okay, let me pull up this other question that was asked. Or actually, if you guys don't have any specific questions, I'm just going to kind of work my way through some of the homecomings, the study guides. I might ping pong back and forth between the two. So if nobody has any specific questions, I'm just going to ping pong for a little bit. Okay. So until you guys ask a question, I'm going to go ahead and do this one. This is another pre-cal. Then I'll do 2 basic math. So I just want to take that and drop it right. Sure. I want to cut this. I'm going to paste. All right. And then I want to edit and crop that. This. All right. My man. All right. Let's go here. All right. Yeah, we'll go with that. Okay. All right. So this is the next question on the pre-cal study guide. Let's take a look at it. So it says, find the exact value of the expression. And let's get that from behind the words. That's a little jumbled. So we'll go like this. All right. So it says, find the exact value of the expression. Okay, we can do this. And let's do some paper. No, that's not good. Just creating some lines for myself. Okay. So now this says, all right, it says find the exact value of the expression. So let's see what we have. We have inverse secant negative 2 root 3 by 3. Okay. So now we have this, and it says write an exact answer in terms of pi. Now we could proceed, intuition, but part of me is like, okay, we're doing inverse secant. Let's just go ahead and identify our domain and range again, like we did before. Okay, now secant. So for secant, what I usually do, secant is the reciprocal function of cosine. So I usually start with cosine of some angle. Now cosine I know is restricted. The domain for cosine goes from 0 to pi, inclusive. meaning we include the endpoints. And then the range goes from -1 to 1. Okay, so but then cosecant is the reciprocal. So I know that like the graph of cosine looks something like it's that S, and then the maxes stay the same. So I know that for secant of theta, the domain goes from, so we still have our 0 to pi over 2, but there's a gap. Okay, we don't include the pi over 2. It's going to be a union in there. And I think we do include the 0 and the pi. So secant, because they share the 0 and the pi, but at pi over 2, cosine is 0, so that means it's undefined for secant. So then our range, it goes from -infinity up to -1. I think it includes that, then union 1 to infinity. Now I think this is just off of pure memory. Let me shrink this down some. But I'm just visualizing the graphs of secant in my head, and we can have a whole discussion on where this is coming from. I'm just trying to keep the pace going. So this should be my domain of range. So then for inverse secant, my inputs have to be between -infinity to -1 or 1 to infinity. That -2√3/3, that looks like it's left of -1, so I think that's okay. All right, so we can proceed. So let's just proceed. So now we have this, and I'll just continue down here, I guess. Okay. So now we have inverse secant -2√3/3, -2√3/3. Okay. So now we said in class that so we'll say this. What this means is that secant of what angle is going to give us a -2√3/3, right? Is that on the unit circle? So if we were trying to solve secant, let me see. Oh, okay. Secant is what? The reciprocal of cosine? So then what this means is what? 1 over cosine of what angle gives us a -2√3/3. We can flip both. So then cosine of what angle gives us -3/2√3. I just flipped the left and the right, right? So then if we rationalize, we'll get cosine of some angle is going to be -√3/2. Okay, so now I think that is on the unit circle. So cosine of what angle, and we said that theta has to be between, and I'm still doing that secant thing. I know this isn't right here, but that should be like a y. Let's look at this. So we got, let me see, I know on the unit circle, if we're at √3/2 for cosine, let me see, 1, 2, 3, that means we're 30 degrees away from the x-axis. We should be in quadrant 4. So it looks like we need to be 30 degrees away from the x-axis in quadrant 4, is what it looks like. Okay, so then what we're going to do, we're just going to, let me see, so for inverse secant, it has to be between, okay, quadrant 4, 30 degrees, 0 to pi. But it looks like our outputs have to go either be in quadrant 1 or quadrant 2 for inverse secant. So third degree. So then we just got to think about the sign. So if we're either in quadrant 1 or quadrant 2 for inverse secant, right? So then, if that's the case, we got to think, not quadrant 4, sorry. We got to figure out what quadrant we're in. So cosine is negative in which quadrant as far as 1 and 2? That's quadrant 2 is where it's negative. So then our inverse secant should be the quadrant 2 result. So I'm going to say 30 degrees away from the x-axis in quadrant 2. Okay. So then if that's the case, that means we're at 180 minus 30 is 150 degrees. So it's looking like we're talking about 150 degrees that we convert to radians. So then pi over 180, 5 pi by 6. So let me try that. Let me check before we back that answer. We're saying that our result is 5 pi by 6. I think that is greater than 1. 5 pi by 6 is okay. I think it's in our right range. Let me check it in the original. Oh, now if we wanted to do this, we got to do some manipulation. So let me kind of go back. Or actually, I'm just going to use another site instead of all of that. I'm using a site called Mathway just to check it really quickly. I think it's okay, but we'll find out. So then we have go to ABC secant. Nope. To the inverse secant, so negative 1. And then we're saying inverse secant of negative 2 square root of 3 divided by 3. Okay, I'm going to close off the parentheses. All right. And then we should get 5 pi by 6. If not, we'll go back and correct it. Yes, we got our 5 pi by 6. Okay. Professor. Oh, hey, welcome. So I see we got another person. Again, since the numbers are the way that they are, I gladly give everybody here right now extra credit. So as people come in, just be sure leave a comment in the comment section, not in the live chat. Live chat is fine, but just leave a comment in the comment section because I'm going to check that later, and just whoever's there, I'll give you credit. So be sure I can find out who you are. Maybe leave your name and what class you're in so that I can quickly find it. And as you guys have questions, hopefully you're going through the study guide. If there's a specific question you want me to work from the study guide, just click on the Ask My Instructor. I'll get an email. I'll incorporate it into the video, and I will go from there. If I don't have any specific questions, I'm just going to kind of ping pong around the two study guides. And if you guys have any questions, just ask, So let me go back to Pearson and check this answer. I think it's here. Yeah. So we got 5 pi by 6. I know that's a little bit bulky. I kind of want to get out of these. Can I get a keyboard to come up? There it is. Okay, so we got 5 pi by 6. Good. All right. So that was correct. Okay, so I'll do a couple from basic math now. So I just go to the study guide for exam 3. Really, if you feel, only reason I kind of keep doing the whole, if you know the study guide, you're good to go, because a lot of people just aren't getting it. And so I was like, well, if it's like this is as simple as I can make it and people just aren't getting it, then it's like, well, I don't see the point in making it more challenging. I mean, I could, but it's okay. It's just my choice. It's just my prerogative. So I'm going to jump around. I'm just going to choose a question at random from basic math. Oh, this is still pre-cal. Let me go back. All right, so let's go like this. All right. No, that's still pre-cal. Why is it still doing that? Let me go here. Guess we need some music or something. It's kind of like dry. But it's okay. I'll get something going at some point. I'm still just kind of working out kinks and playing around. 5 and 6, yeah. All right, so I'm gonna just choose something at random for basic math. All right, so this says factor trinomial. This is a good one. All right, so let's do this. We want to drop this here, and I'll when I'm done, I'll leave a PDF of the questions that I'm working here in all of my classes so that everybody can access it. So I'm gonna just put this back to blank. Put this back to blank. Okay, and let's take a look at this. So in this one, we want to edit. We're gonna crop. All right. So here, let's go over here. All right. So now this question, it's just one of the questions from the study guide. It's like I think it's question 13 from the Basic Math study guide. So it just says to factor the trinomial completely. Okay. So let's attempt to factor this. Okay. And I'll just do some paper. Space like this. I want paper. I want line paper. All right. So we're gonna go here. All right. Okay, so let's factor this. All right, so we have 3y to the 4 minus 14y squared minus 24. Now, so also a word, so some of my students in the past, they made it a point to go out of their way to make sure to work every question at least 3 times. Even if they got it right, they will work it multiple times. You know, what you really want to do is kind of take the material and write the questions down and only have the questions. Don't have anything else, no support or anything. You want to try to recreate or simulate the testing environment. So if you can just have a list of questions with no support and answer them all comfortably, that's a pretty nice place to be sitting going into an exam. What we do the longest, we do the strongest. You know, one of my teachers would say things like, you know, you don't want to work something until you get it right. You want to have done it so many times that it's impossible to get it wrong. So that's the kind of proficiency level we're trying to have. So if we look at this one, we have 3y to the 4 minus 14y squared minus 24. First question we want to ask ourselves is there a GCF, or greatest common factor? So I'm thinking, oh, maybe they all have y. They don't all have y. No GCF here. Okay. So we're going to use a technique called substitution method. Okay. So we're going to let u be y squared. Okay. So we're going to let u be y squared. So every y squared we're going to replace with u. So then ours now becomes 3u squared minus 14u minus 24. Okay. So now we have a quadratic that we know how to handle. So we're going to use a technique called the AC method. So if we say the 3 times the 24, we get our answer. Let me see, 24 is 3 and 8. So this is really 9 and 8. So 72. So we're looking for two numbers that multiply to give us negative 72 and add to give us 14. Now 72, we said was 9 and 8. So that's 2 times 2 times 2 times 3 times 3. Okay? So we're going to go down the list of factors until we get to the line that adds up to negative 14. So then we have negative 1 and 72, so that's no good. Negative 2. Now if we've used the 2, we have a 4 and a 9 left over, which means we have 36. But notice that adds up to 34, so that's no good. Then we have negative 3. Now if we use a 3, we have an 8 and a 3, which is 24. That adds up to 21, so that's no good. So then we go 4. If we use a 4, we have a 9 and a 2, which is 18. Okay, this adds up to positive 14, but we want negative 14. So, what was the, Mr. Chapman, welcome. Okay, so as gentlemen arrive, you want to leave a comment in the comment section, not in the live chat window. That's fine, but just be sure that you're leaving your comment, you know, with your name and class in the comment section, because that's what I'm going to check later, not the live chat. You know, you can ask your questions and things in the live chat, but leave your info in the comment section so I can pull it later. So what we're going to do is switch the signs here. We're going to say 4 and negative 18. This is the line that we're looking for. Notice they multiply to give us negative 72. 40 plus 32 is negative 72. And then they add to negative 14. So we're going to rewrite this negative 14 using the 4 and the 18. Now I'm purposely going to put the 18 next to the 3 because they have something in common. So then I'm going to say 3u squared. And I'm going to rewrite that negative 14 as negative 18u plus 4u minus 24. Okay. And I'm going to shrink down this other stuff that I'm not using right now. Okay, so here's that. All right, let's keep going. Okay, so then we're going to use a technique called factor by grouping. So if we look at the first two, what do they have in common? We can factor out a 3u. Everybody's leaving the comments here, gentlemen. Oh, I guess it's because of what it says. Yeah, just came in. Yeah, be sure to leave your information in the comment section, not in the live chat, but in the comment, because once I close the live chat, I'm not going to have access to this. So leave it in the comments with the name and your class so I can find you later. Okay, so we can factor out a 3u, and then what's left is u minus, what is it, 6? Okay, so the hint is that we're looking for a common binomial factor, and this is what we're going to be looking for in the second half. So we're also going to be looking for another u minus 6. Now, what can we factor out of the second two? We can factor out a 4. We got our u minus 6. Okay, so that's good. So then we factor out our common binomial factor. It's almost like that common binomial factor merges and goes in front. And then what's left is 3u plus 4. Now, the final step, put the substitution back. So then we'll get y squared minus 6 times 3y squared plus 4. No more factoring because we don't have any difference of squares. My claim is that this is the factor form of the original, this here. Okay. Now, with something like this, if you're on an exam, all you would do is FOIL or multiply back to check and make sure that it works. Okay. Sure, it's no problem. Yeah, just log in so that I know that people are connected and they're seeing it. So it's no worries. If you have any specific questions, you can ask. Click on the Ask My Instructor. I'll get an email. I'll incorporate it into the video. Matter of fact, let me check the emails real quick. Oh, I do have some. I have one. Okay, so I'll do that request next. Oh, actually, yeah, I'll do that one next. Okay, so let me go back. I want to check this result. All right, factor completely. I think this is completely factored. All right, so we're saying that the result is, maybe I can type this as well. I'm going to try typing this. So I got parentheses, yes. Y, nope, not that. Y squared minus 6, close parentheses, open parentheses, 3y squared plus 4. I'm going to hit enter. Fantastic. All right, so now, that one was correct. So there was another question that came in, so I'm going to go ahead and incorporate that one. I'll go here. Can I just copy the link or something? Then what I want to do is go back here and just do a new one. And I will paste. Go. All right. So this one says find the square. Okay. That's not too bad. So let's incorporate it. We're going to drop it right here. Edit. Done. All right. Let's edit a little bit more. All right. So this question, that's a little big, but that's okay. So this is a question that someone asked. It said find the square. So let's just take a look at it. All right. So we have 3z plus 2 quantity squared. What this means is binomial multiplied by itself. So something squared just means multiply it by itself twice. 3z plus 2. Okay. So then if we FOIL, first and first is going to be 9z squared. Outer and outer is 6z. Inner and inner is 6z. And last is 4. So then if we combine like terms, we get 9z squared plus 12z plus 4. And let me put it in there. Oh, that's my claim, so I'm not gonna. I don't think it's gonna let me put that answer in there. Okay. So that's what I got for that one. Let me do a couple more. Okay. I think I'm gonna do a few more pre-calcs. So my last few sessions have been entirely basic math, which is fine. But I'm going to work a few more pre-calcs unless I get some requests. Because I think the pre-cal I didn't get that too much time to kind of go through some of these, so I wanted to take some time now. But I have to have questions in order to give answers. Yeah, I mean, I'll go back to the courses. Pre-cal. You hear the geese outside? Guess I haven't. The weather is nice right now. It's nice. All right. So I'm going to just jump around and choose another random question from pre-cal. Okay, this is good. So let's look at this. All right, so now we have this question. So it comes from section 47, question 53. It basically says multiply and simplify. We have tan of x minus 1 quantity squared. Okay, so let's do this multiplication and see what comes out. So now if we have tan x minus 1 quantity squared, this means tan of x minus 1 multiplied by itself twice. Tan of x minus 1. Now if we FOIL, first and first is going to be tan squared x. Outer and outer is minus tan x. Inner and inner is minus tan x. And last is plus 1. Now I think that tan squared plus 1 is something. Now I don't really remember, I only remember one main trick I didn't do, which is sine squared x plus cosine squared x equals 1. Now if I want to convert this to tan is what? Sine over cosine. So I'm going to divide everything by cosine. Now if I do this, let me see, then we'll get tan squared x plus 1 equals secant squared x. So we see we have a tan squared x plus 1, so those two together give us secant squared. Okay. So then what we have is secant squared x minus 2 tan x. Is that up there? Can we do anything further? Can we simplify anything further? Any canceling? I don't see anything. I'm thinking that B might be our solution. Secant squared x minus 2 tan x. Let me try that one and see what happens. That is correct. Okay, so B. And so like now really on the exam, with something like this, I usually don't do any partial credit for multiple choice. Yeah. So that's what happened with like one of the exams. There was like a lot of multiple choice, and there was like some bonus. So, you know, if you didn't go for the bonus and you didn't get perfect on the multiple choice, then it could really mess you up. I'm going to do another one. So here's another one. I'll go here. Let's put this here. And I want to edit this. Shrink that down. Here. Here. All right. So now we're taking a look at this. All right. Let's look a little bit. Okay, so it says establish the identity. We got cotan of v, blah blah blah. Let's verify this. Actually, yeah, let's do it ourselves. So now we have cotan of v minus 1 over cotan of v plus 1 equals 1 minus the tan of v over 1 plus the tan of v. Tan of v. Okay, so we just need to try to arrive to one of these conclusions. Now they have 1 minus, they have the cotan. Okay, so what they're doing, they're applying the definition of cotan. So cotan is 1 over tan. So that means we're going to have 1 over tan of v minus 1 over 1 over tan of v plus 1. Okay. Let's see what they did next. So then usually when you have a complex fraction, so all we're really doing is starting with the left and finishing with the right. So let me move this up here. Okay, now this is correct. Now to get rid of the fractions, we usually multiply the top and bottom by the denominator, the LCD of the denominator. So then we would do tan of v over a tan of v. So we're really just multiplying by 1 in this form so we can get what we want. We're going to distribute, and we'll get, so the first one goes to 1 minus tan of v over 1 plus tan of v. And is that the first one? Yeah. Yeah, okay. So if we look at, let's look at our results. So if we look at our results, cotan of v, the only thing that's really different is that first step. They want to see if you really know what cotan of v is. Because the first one they did, cotan was 1 over tan. The second one they said that cotan was 1 over cosecant. And the third said multiplied by the conjugate of the numerator. I don't know if that trig identity is correct. We could check it, but it looks like the first one worked because we got the same result. So I will go with A. Let me check A. That is correct. Let's see what's that probably that identity. Oh, yeah. That last one it doesn't really sit well in my system. Okay, let me check my messages once more. So yeah, I have to fix that. Okay, so I don't immediately see any other questions, so I'm going to close it out there. Otherwise, gentlemen, we'll call it a day there, and have a good weekend. So from one beautiful mind to another, I'll catch you next time.